All right, so this week I also wanted to do an introduction to trigonometry, which is our big topic for next week. So if you don't fully understand by the end of this week, that's okay. We'll have lots more practice next week. But I wanted to introduce this vocabulary so that when you see it next week, it's familiar to you. Because this topic shows up a lot on like ACT, AccuPlacer, other like entrance exams. It'll show up if you're an academic decathlon, it shows up there. This is the sin, cos, and tan, otherwise known as sine, cosine, and tangent. So this is a pretty important topic, which is why it's one of the key topics that made it into this distance learning. So I wanted to introduce it. Okay, so this is called trigonometry, which is the study of how the sides in a triangle relate to the angles in the triangle. And there are special patterns that show up in right triangles, which is what we will look at in this class. So just like Pythagorean theorem, we're dealing with right triangles. Let's see. So, remember in similar triangles when, maybe I can draw it out. You have two different triangles and there's a scale factor between them. Well, it turns out within right triangles themselves, in similar right triangles, there are certain ratios between the sides of just one triangle. So for example, take this right triangle on the page. Let's see, we got a leg here, A, and a leg here, B. Turns out in any triangle with, let's say this X, what does that look like? Let's call it 30 degrees. Turns out any triangle, any right triangle that has 30 degrees, the ratio between side A and side B is always the same. And that's when you get these little ratios down here. Because since this ratio B over A, for example, compared to that angle 30, is the same no matter what those lengths are. So if we make this triangle bigger or smaller, but keep that angle the same, this ratio is always going to be the same. And later on in this module, when you do the Desmos activity, you will explore this idea more, okay? Anyways, so this ratio, this B to A, is the same in any triangle, any right triangle where you're dealing with this 30-degree angle right here. And this ratio, we call it, we give a name. We give it either a name of sine, right here, cosine right here, or tangent right here. So to understand these, I think I need to give these sides labels of opposite, adjacent, and hypotenuse. So I'm going to go ahead and just clear all of this. Okay, so first off, you need to know what the reference angle is. And you can choose your reference angle as long as it's not the 90-degree angle. For us, we're going to choose it to be x. And that just means our side lengths, our sides, what we name them, will depend on this reference angle x. So let's start with hypotenuse. We know that one. That one's the side opposite that 90-degree angle, the longest side otherwise. So OT. Bear with my handwriting. We're writing on a Chromebook here. Okay, this long side is the hypotenuse. Now, which side do you think is the opposite side? It's the side opposite x. In other words, the side that doesn't touch that angle x, which is over here for us. So opposite. Which leaves the adjacent side to be the leg of the triangle that touches that reference angle. So this is the adjacent side. So now there are different ratios that will relate the sides of the triangle compared to the angle. So for example, sine of this angle, which is the ratio of this, whatever this angle is always the opposite side over the hypotenuse. The cosine of this angle x is the adjacent side over the hypotenuse. Lastly, tangent of this angle is the opposite side over the adjacent side. So we're dealing with the two legs with tangent. And these are actually functions, but we're just going to be dealing with the ratios here for the most part. So that means, I believe I have an example below. To find the trigonomic ratios sine x, cosine of x, and tangent of x, given these side lengths. So we are going to say that this is a Pythagorean triple. This side length we'll call 3. We'll just say this one is 4, and then the hypotenuse is length 5. Okay, so sine of x equals the opposite side. Well, here, let me just label these. The reference of x, and this is just like above, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So sine of x is opposite over hypotenuse, which is 3 over 5. Cosine of x is the adjacent side over the hypotenuse, which is 4 over 5. Lastly, tangent of x is equal to the opposite side over the adjacent side, which is 3 over 4. And that's really the basics of this concept. There will be more next week specifically where you can use your calculator. So if you see your calculator, you see the sine, cosine, tangent buttons. They look like this, SINCOSTAN. And we'll learn how to find that angle, x. So you can actually find what this angle is given these measures, or given these measures, and given this little equation right here. So that's it for this example. Let me know what questions you have. Work through that Desmos activity to get you familiar with these ratios and why they are true. And please email me with any questions. Come to my office hours. But that's it for the content this week. So I hope you have a good week.